Hello, welcome back to my YouTube channel. My name is Talha Saab, and today we are going to see how a basic line follower works. LFR line following robot. How does it work and which sensors are used? So let's go on to it. We are using Proteus software in it because the Proteus have samples already present in it. We'll use them. So if we go on to open sample, we search about turtle. So we have different options here. Let's use follow and avoid one. So yeah, this is the virtual turtle follow and avoid bot already built in it, and it's designed in Visual Designer. So this is the sensor that is being used in it, and it's a sonar sensor. And the work of line follower is if we make a path and we put on it, it reads the path and work and move accordingly to the path. So it can be integrated with different sensors like IR sensors or the ultrasonic, the sonar sensors. Different arrays come for it like the Pololu and every other. So I've used as a Pololu QTR array. It's a good one. The response is good. So here I guess they are using the sonar, and we can identify the pins if we use the connectors here. Let's see if we can do that. Okay, if we were to remove these, and if we put this here, yes, so it tells us what each pin is doing. So the first one is the trigger, the second one is the echo, and the third one is the servo. So the trigger is for the sonar and the echo also for the sonar. Then we have these two motors. We can see their pins too. If we just delete them, put this one. This is the in1, in2, and the enable. Same goes for this one. Now we don't want to delete. I just want to delete the wires here. If I can do that, yes, of course I can. Then my bad. Okay, so let's just rotate them so we can see. Yeah, so the in1, in3, and in4, and the enable pin for the motors here, and this is the sensors. So if we do user triggers for them, so yes, so now we have identified all the pins that are being used here. This is a sonar, it's a trigger and echo pin, the servo pin, the servo that is rotating, and the sonar is attached to it. So it will move, and the sonar will take readings, and the echo actually is the input that it's giving to, and the I'm sorry, the trigger is the one that giving input, and the echo is the receiving one. So the trigger, the long as it moves, and the echo, the time it takes, the distance is divided, and some formulation takes place, and a distance is calculated through it. Then the motors are working accordingly, the left and right motors, and then this is a sensor that is reading the line, the line, the path that is going to be followed. This sensor is going to read it, and the sonar is used for avoiding obstacles. So now that we have identified the pins, I guess let's see how it works. So let's get it running. So yeah, this is our turtle robot, and it's following the line. So the line is just drawn in a paint application. You can make your own path, and it can be used to check if it will move on it or not. So if you can see the lights, the green lights that is turning on, it means that the sensor is detecting the line and is working on it. And if the blue array shows that the ultrasonic is searching for obstacles, any obstacle in its surroundings. So yeah, this is how it works, and we can also manually control it if you want to. Like if we remove, let's first stop the simulation. If we remove these wires, also these, and if we use the logic toggle here, logic toggle, let's place this one here, here, and here. Let's connect these. I guess it's connected. We can, let's just first mirror them so they can be. Now let's place them somewhere here. Now let's make the connections. So yes, let's see if this central one is connected. I'm doubting it a little. I guess it's connected. So we can toggle the value. So now the bot will be controlled by us manually. Now we can control it manually and give it input, and as the way we give input, it will work accordingly. So if I enable this one and lower, high, it will rotate. And for this, if we enable this one, it will be rotating. So yeah, now we are controlling it manually. The manual control is used if we are connecting it to a microcontroller, like any microcontroller. You can use Nano, Mega, ESP32. In the AVR, we can use Arduino Uno or Nano or Mega. But for a project like this, Nano is enough. We do not have. We need to use our resources. So Nano is cheap, and you can use it for it. So if you want to control your bot manually, you can use it using the toggle and connect it to the digital pins of the Nano and control it manually. Or maybe you can also control it via Bluetooth and control it through your phone. You can connect the Bluetooth with your phone and use that. So let's see another example where we can use that one. So this was the turtle robot, that is the line following. Another we have developed is this one. So in this, uh, it is not following the line, but it is following instructions. The set of instructions we are giving it, it will follow that, the source code we have written for it. So here's the source code. The source code I will put it in the description if anyone wants it. So we have defined the pins here that are using in the microcontrollers, then the pin mode of every other, then how it's going to read it, and the functions, and also the uh, conditional statements. Then the digital write, high, low, everything. So the PCB layout, we have developed the PCB layout for it, but this is how it is. So if we run it, the virtual terminal, the new thing here is we have used the virtual terminal here, and the virtual terminal can be accessed through there. The oscilloscope, where the oscilloscope, you can use the virtual terminal from here, and let's run it. So let's go to debug if the doesn't show up. So yeah, it's a virtual terminal, and then we have the virtual terminal T1, but this is moving, so I can control it through my keyboard. And if you want to control it through your microcontroller, you can connect it And also, so if you want to connect it with your microcontroller, you need to use a Bluetooth module. If you're using Arduino, then you need to use a Bluetooth module or a Wi-Fi module, and then connect it to the phone via Bluetooth or Wi-Fi, the protocols you're using. Or you can just use an ESP32. It has a built-in Bluetooth and Wi-Fi, and it's cheap. So we need to utilize our resources as much as we can. And after you integrate with it, so you can write the code in it, and you can simulate also in the Proteus. So here's the robot and the virtual terminal, and I am also designing it in the Easy EDA. If anyone doesn't know, then Easy EDA is also software like the Proteus. It is also used to develop electronics. So this is my uh, schematic diagram for the LFR. I'm using an Arduino Mega and the motor driver L298, a sensor of QTR array Polulo, and a color sensor ultrasonic. The color sensor is basically used to color sense the obstacle color. The ultrasonic is used to sense the obstacle, then the color of it is sensed by the color sensor. And we are also using the SD card module. SD card module would do that. It will store the data of its path and the reading of its voltage and everything in a backup. So if I need to use the data afterwards, then I have access to my data. It will be stored in the module. I'm using an OLED display here. The OLED display is used to show the battery health and also the voltage that it's having in the currents also. And I've been designing the PCB for it, but it's not complete yet. I'm working on it. So in the next video, I'll show you the when it's complete, and I'll share with you the working video of it. So see you next time. Thank you for watching. Goodbye.